welcome to week 4 of an introduction to paleontology with the Safe Cultural Heritage Group. This is the one that I'm pretty sure everyone will be looking forward to, as it is the rise and fall of the dinosaurs. In today's lecture, we will be learning what dinosaurs are, or were, key dates, paleogeography and paleoclimate, key fauna, cultural depictions of dinosaurs, the theropod to bird evolution, and the end Cretaceous Mass Extinction. So, what are dinosaurs? Dinosaurs are a group of reptiles from the clade Dinosauria. Dinosaur in Greek means terrible lizards, and this was first coined by Richard Owen in July 1841. To announce these organisms as a new group, his initial speech to the British Association allegedly lasted 2 hours. And dinosaurs are part of the archosaurs, which include dinosaurs, pterosaurs, and modern crocodiles, as well as extinct crocodiles. And dinosaurs can be split into two: the avian dinosaurs, which are also known as the birds, and the extinct non-avian dinosaurs, which are all other dinosaurs other than birds and the bird family tree. So they first appeared in the early Triassic, but they were not the dominant organisms until after the Jurassic-Triassic extinction. And dinosaurs do not include the pterosaurs and marine reptiles. And the only extant species of dinosaurs are birds. Fossils have been known about for millennia, however they weren't really recognised as such. For example, Chinese and Eastern Asian countries believed them to be dragon bones, whereas in Europe, dinosaur fossils were generally considered to be the remains of giants and other biblical creatures. The Blackfoot Nation in North America, around about the 1700s, this was first documented, they thought that dinosaur fossils were thought to be the remains of giant buffalo, and they used these dinosaur bones in rituals which were intended to ensure good hunting. So, for the history of dinosaurs, we're going to look at a case study. The first ever dinosaur to be described was called Megalosaurus. And this was first described by William Buckland. This fossil has been known about since the mid-1600s, as a Dr. Robert Plot, who was the first keeper of Oxford's Ashmolean Museum, had illustrated it, shown as this image on the bottom left. In 1763, Dr. Richard Brooks labelled it as Scrotum humanum, stating that the stones that have been found exactly represent the private parts of man. Yeah, okay, so this is a fossil that was called Scrotum humanum, however it was actually the first ever dinosaur bone described, which is now known as Megalosaurus. The second dinosaur genus to be identified was Iguanodon, which is a much more famous dinosaur, and it was discovered in 1822 by Mary Ann Mantell, who is the wife of the English geologist Gideon Mantell, aka Darwin's bulldog. And on the top image on the then, we would call it, this was one of the Crystal Palace dinosaurs here in the UK. And this is the Megalosaurus from the Crystal Palace dinosaurs. And these were created in 1852 by Benjamin Waterhouse Watkins, advised by Richard Owen, to accompany the Crystal Palace after its move from the Great Exhibition in Hyde Park. In this, there are, in the kind of dinosaur section, there's one model of Megalosaurus, one of Hylaeosaurus, and 2 Iguanodon models. However, this is quite a primitive outlook on what dinosaurs look like, as it kind of looks a bit like a rhino and an iguana mixed together. However, now we know that it was a bipedal, kind of more carnivorous dinosaur. So, what constitutes a dinosaur? all dinosaurs have 12 synapomorphies, which we know as characteristics present in an ancestral species and is shared exclusively by its descendants. So dinosaurs have around 12 unless they have secondarily lost, which was done in a study by Nesbitt 2011. So here are some key ones to remember. First being a erect gait with the femur held vertically and the femoral head offset at an angle. So previously to this, the kind of main gait was sprawling, like a lizard would, or semi-erect, which is kind of in a bit, but not fully like how we would walk. For example, we are fully erect gait. So the dinosaurs had this change from the sprawling to the erect. An ilium, which is part of the pelvis bone, with a posterior brevis shelf, and this is for muscle attachment. The next one is a femur with a curved shaft, which you can see here. The human femur has quite a straight and narrow shaft between the two condyles, whereas dinosaurs seem to have a bit more of a curved one. A humerus with an elongate crest, which you can see really well in this Allosaurus humerus, and this is good for attaching the deltopectoral muscles. An ascending process of the astragalus. So the astragalus is part of the ankle bone bones, and here you can see it kind of tapering quite nicely up along the tibia. And finally, a quite debated synapomorphy that is still kind of contested, a broader distal end of the tibia. We'll now move on to the Cretaceous, which was the longest geological period of the entire Phanerozoic. It spanned 79 million years, from 145 to 66 million years ago. And the Jurassic Cretaceous boundary is the only boundary, geological boundary, to lack a defined stratotype section and point, as it is really hard to define in the rock record. So in the Cretaceous, dinosaurs were the most dominant animals of the period, with many modern animals, such as the placental mammals and the marsupials, evolving. In the oceans, mosasaurs had evolved in the late Cretaceous, and ichthyosaurs had become extinct during the late Cretaceous. In the early Cretaceous, flowering plants known as the angiosperms appeared, with the first one appearing roughly 122 million years ago, and diversified, replacing the gymnosperms. There's new evidence in 2021 by Silvestro et al., which might suggest possibly an earlier origin date of the angiosperms. And the end of the Cretaceous is defined by the Cretaceous Paleogene Mass Extinction, where roughly 3/4 of the plant and animal species on Earth died, which primarily were the non-avian dinosaurs, pterosaurs, as well as the marine reptiles. The Saurischian dinosaurs, there are 3 main taxa: the Theropoda, the Prosauropoda, and the Sauropoda, and they range in dates from the late Triassic to the present. And the Theropoda, which is the sister taxon to Sauropodomorpha, is the most differentiated group amongst Saurischians. And the reason why they are still around today is because birds derived from these lizard-hipped dinosaurs from the Maniraptoran clade within the Theropoda. We will be going on about this in a second. The Ornithischian dinosaurs include all non-avian dinosaurs, and they were primarily herbivores. So if you think of your general herbivorous dinosaurs, you think of your Triceratopses, Hadrosaurs, Stegosaurs, and Ankylosaurs, and these were all from the Ornithischian clade. They date from the early Jurassic to the end Cretaceous, where they all died in the end Cretaceous Mass Extinction. And the exact placement of Ornithischia within the dinosaur lineage is still a bit of a phylogenetic issue. The overall phylogeny of dinosaurs is consistently changing and being rearranged. So a big case example of this was in 2017 when they rearranged the 2017, when Barron et al. Rearranged the phylogenetic tree, where they stated that some theropods were more closely related to Ornithischians. And what they did was they kind of reshuffled all the clades and created this new clade that included the theropods and the Ornithischians, known as Ornithiscalida. Let's move on to the Triassic dinosaurs. The oldest true dinosaurs have been found in the earliest part of the late Triassic. The oldest known dinosaurs are known as Eoraptor, Herrerasaurus, and Saturnalia, and these are all Carnian dates, so 237 to 228 million years ago in the late Triassic. These dinosaurs were all small and bipedal. Saturnalia was found in Brazil first, and it's thought to be a basal sauropodomorph, as it demonstrates both sauropod and theropod traits. And it's thought that Saturnalia was carnivorous, however, they are a bit unsure about this. Eoraptor was found in Argentinian deposits, and it's around a metre long. It has numerous dinosaurian characteristics. And Herrerasaurus was originally found in Argentinian deposits. It was a lot larger and more bulkier than Eoraptor, and it was roughly 3 metres long. It was originally thought that Eoraptor and Herrerasaurus were basal theropods. However, it's now thought that they are basal Saurischians, or even an outgroup of the dinosaurs. We will start with the Triassic. So the Triassic spans 50.6 million years, from 251.9 to 201.3 million years ago. And both the start and the end of the Triassic are marked by major extinction events. So the beginning of the Triassic was at the point where the Permian mass extinction occurred, and this wiped out around 80 to 90% of marine life, as well as 70% of terrestrial life. And in the Triassic, the first true mammals evolved, the first flying vertebrates, which are the pterosaurs, evolved, and as well as this, dinosaurs evolved. And the fauna was dominated primarily by these little guys known as rhynchosaurs. And these were extinct herbivorous archosauromorph reptiles, and they are found sometimes in deposits they make up for about 40 to 60% of all organisms found at a locality. They had a worldwide distribution, being found across all of Pangaea. And it's thought that they died out kind of in the middle to late Triassic period. In the Triassic, almost all the Earth's landmass was concentrated in Pangaea, centred on the equator, and spanned from pole to pole. There were desert belts at around 10 degrees to 30 degrees latitude, and it's thought that there was rifting that occurred. Well, there was rifting that occurred during the late Triassic, but Pangaea had not yet separated. The Triassic climate was a transition from an ice house to a greenhouse climate, and it's thought that there was a monsoonal climate due to the positioning of Pangaea as well as the Tethys Ocean. When we talk about dinosaurs, we always talk about them being within the Mesozoic, which means middle life. And that name was proposed in 1840 by the British geologist John Phillips. So the Mesozoic is composed of 3 different time periods. The Triassic, which dates to 251.9 to 201.3 million years ago. The Jurassic, 201.3 to 145 million years ago. And the Cretaceous, which was 145 to 66 million years ago. The Mesozoic is known as the Age of Reptiles, or the Age of Dinosaurs. And the Age of Reptiles was introduced by the 19th century paleontologist Gideon Mantell. It began with an extinction and ended with an extinction. So it began with the Permo-Triassic mass extinction and ended with the Cretaceous Paleogene mass extinction. And the Mesozoic had an abundance of conifers and ferns, as well as angiosperms flowering plants starting to form, as well as it having a hot greenhouse climate. And as well as this, during the Mesozoic, the tectonic breakup of Pangaea was also occurring. The most common late Triassic dinosaur is Plateosaurus, which was found in deposits from 214 to 204 million years ago. And what Plateosaurus is, it's a basal sauropodomorph dinosaur and was a roughly 7 metres long. They're not sure whether it was bipedal or quadrupedal. However, a study done in 2010 found that Plateosaurus could not have weight bared on its front limbs, meaning that it was most likely bipedal. And it's also thought that they were herbivores because of their teeth morphology, as it has a serrated tooth edge. And they don't think paleontologists could not believe that they couldn't have chewed using a sideways jaw motion like a cow, so they would have just swallowed plant material whole. Let's move on to the Jurassic. And the Jurassic is probably one of the most recognisable and most famous geological time periods. It spanned 56.3 million years, dating from 201.3 to 145 million years ago. The Jurassic began with the Triassic Extinction event, and this is associated with the eruption of the Central Atlantic magmatic province. So the rifting that we have in the North Atlantic and South Atlantic, this caused the extinction event in the Triassic and Jurassic. The terrestrial fauna was dominated by dinosaurs, however the oceanic fauna was dominated by marine reptiles, and the pterosaurs ruled the sky. So, the first appearance of birds also occurred during the Jurassic, however pterosaurs were the most dominant flying vertebrates. As well as this, in the Jurassic, there was the first appearance of the earliest lizards and the evolution of therian mammals. Jurassic, like paleogeography and climatic-wise. So during the start of the Jurassic, Pangea started to break up, and then this was accelerated with the North Atlantic opening as well between Europe and Africa. Laurasia, which include North America and Eurasia, broke up, and then Gondwana, which contained South America, Africa, India, Australia, etc., and Antarctica, began to break up by the mid-Jurassic. The continents were surrounded by the Panthalassic Ocean, with the Tethys Ocean forming between Laurasia and Gondwana. And in the Jurassic, sea levels rose, and this is known as a transgression. Climate was a lot moister than in the Triassic, with warm conditions in the polar regions, and this is shown by fern and conifer fossils in the Antarctic. Move on to the Jurassic dinosaurs. In the Jurassic, sauropods were the dominant large herbivores in the terrestrial ecosystems. And as well as this, the earliest avellands, which are the clade that contain the only living dinosaurs, the birds, and their ancestors, appeared during the middle to late Jurassic. And the avellands were represented by Archaeopteryx, which is found in the late Jurassic Solnhofen limestone in Germany. And the earliest definitive Ornithischians appeared during the early Jurassic. And these are represented by basal ornithischians like Lesothosaurus, Herodontosaurids, and early members of Thyreophora. And Thyreophora are the ankylosaurs and stegosaurs, and they appeared during the middle Jurassic. One of the best ways that we can distinguish between dinosaurs is the hip structure. So there's two major subclades within Dinosauria, and it's primarily divided by pelvic structure. However, there is also skull and other skeletal characteristics that can separate the two. So with we have the Saurischian, which means reptile hips, and this is the more primitive structure of the two pelvises. And what it is the pubis points forwards and the ischium backwards. And the Ornithischians means the bird-hipped, and this is where the pubis runs in parallel with the ischium. It should be noticed, however, that birds do not come from the bird-hipped dinosaurs. Some famous Jurassic dinosaurs include Allosaurus, Brachiosaurus, Diplodocus, and Stegosaurus. So one thing that I always remind myself is that not all dinosaurs occurred at the same time period. So when you see art that depicts a T-Rex killing a Stegosaurus, that would never have happened. So I always think of Allosaurus and Stegosaurus, and then T-Rex and Triceratops. So the two T's and then the two Sauruses together. In the Cretaceous, Pangaea had completed its breakup, and we had Gondwana, which included South America, Antarctica and Australia, rifting away from Africa, though India and Madagascar remained attached to each other until around 80 million years ago. And during the mid and late Cretaceous, there was extremely high sea levels, which was over 100 metres today, due to mid-ocean ridges raising the sea level floors. And we know this because North America was divided by the Western Interior Seaway, Europe was small islands, and then there was also flooding and oceanic transgressions in South America and Africa. At the peak of the Cretaceous's sea level transgression, 1/3 of Earth's present land area was submerged, and this led to large amounts of chalk being deposited. The climate, it's debated as to whether it was warm with no ice on the poles, or whether it is a cooler climate throughout the entire period. Isotopic data, however, suggests a warm temperatures in the late Jurassic and most of the Cretaceous, and then a major cooling trend in the latest Cretaceous. And we know that it was warm during the Cretaceous as there were rainforests in Antarctica, and this is shown by the pollen and spore record that have been found in the ice in Antarctica. Here are some examples of just Cretaceous dinosaurs. We've got T-Rex, Velociraptor, Iguanodon, Triceratops, and an example of a Titanosaur. We need to take into consideration some biases surrounding dinosaur paleontology. So it was heavily biased towards Western paleontology within, for example, North America and Europe. But however, within the last 30 or so years, the focus has shifted onto Asia, primarily China, Africa, which is primarily Morocco, and Australia. And we'll see an example of this quite heavy bias towards Western paleontology on the next slide. We also have identification biases, where we have collectors creating new species or genera for possibly juvenile specimens of a known dinosaur, an example being Nanotyrannus, which was created by some fossil collector in America. However, that we think is just a juvenile species of T-Rex. And we've also got a big bias of academic versus commercial biases, where dinosaur fossils are being sold to very rich people, not allowing people to have access to them for study. An example being the original Stan the T-Rex was sold at auction for $31.8 million. I grew up looking at a Stan the T-Rex replica here in Manchester Museum, and it just really saddened me to know that the original had been sold. And David Evans from the Royal Ontario Museum said that if this kind of money, aka the $31.8 million, were invested properly, it could easily fund 15 permanent dinosaur research positions, or about 80 full field expeditions a year. And the reason why a lot of people were up in arms about this is because researchers and the public could lose access to fossils, meaning that we can't really repeat the results, such as measurements of its bones or conduct new analysis with more advanced tools or techniques cannot be completed. Which just really sucks, you know? We'll just see here, you can see on this slide where quite a lot of where fossils of dinosaurs have been found. For the Jurassic and Cretaceous, as you can see, there's quite a heavy focus on the Western paleontology. And this is from a website called the Paleobiology Database, which is a really, really useful tool where you can just look up any sort of fossil that you want to and see where it has been found. It's really useful. I would definitely give it a look. I've always been part of the media, whether it be in terms of paintings or statues or in films and TV. So the cultural depictions have created and possibly even reinforced misconceptions about dinosaurs and other prehistoric creatures. An example being that Dinosaurs were featherless, slow-moving, scaled, roaring organisms. We know now from much better fossils that some of them were feathered and quite quick. Another one being Jurassic Park's interpretation of certain dinosaurs. I know I touched on this in the first lecture. Example being Velociraptors being the size of Deinonychus instead of their actual size. Dilophosaurus being 1.2 meters tall, which is a lot smaller than its actual size in real life. And that dinosaurs like Dilophosaurus could spit venom, which is, again, there's no conclusive evidence of this, and that we can extract dinosaur DNA from mosquitoes. As cool as that would be, it doesn't really work like that. And then finally, that different extinct animals, such as animals from the Permian, like Dimetrodon, and woolly mammoths and Neanderthals and humans from the Pleistocene, all live together with dinosaurs. That's a big pet peeve of mine. Cretaceous dinosaurs are probably one of the best known in the world. Dinosaurs during the Cretaceous were the most dominant terrestrial life forms. And at the start of the Cretaceous, there's a mix of Jurassic-like species as well as newer forms. And at the end of the Jurassic, some of the large sauropods, such as Diplodocus, went extinct, and these were replaced by species such as the titanosaurs. And dinosaurs from the last 10 million years of the Cretaceous that have been found in North America are some of the best known in the world, for example, T-Rex and Triceratops. And during the Cretaceous, Ornithischians such as the hadrosaurs really thrived, which led to them gaining the title of being the cows of the Cretaceous. On to the dinosaur to bird evolution. So the birds evolved from small reptiles, small theropods, not large ones like T-Rex, and that they evolved around 165 to 150 million years ago, which is from the middle to late Jurassic. For a few centuries, Archaeopteryx from the late Jurassic period was considered to be the earliest bird. And the first evidence that birds evolved from reptiles appeared in 1861, which was only a few years after Darwin published On the Origin of Species, which was Archaeopteryx, which had a mixture of classic bird-like features such as feathers and wings, but also retained sharp claws on the hands, a long bony tail, as well as other reptilian characteristics. And then John Ostrom, who is a famous paleontologist, discovered fossils of bird-like dinosaur known as Deinonychus from the western North America. And then we move on to China, and in 1996 they released these amazing photos of fossil birds with feathers. And this is really interesting because as more fossils are found, it's becoming more clear that the earliest birds were very similar anatomically to the primitive dromaeosaurs and troodontids, which are part of the Maniraptora, which are the small theropods that birds evolved from. The oldest birds and their relatives were small, and they were roughly chicken-sized, lightweight, long-armed, winged and feathered. And the birds diversified through the Cretaceous and Jurassic and Cretaceous. So birds diversified primarily during the Cretaceous, and this is recorded by the fossils of the Jehol biota in China, and which dates to approximately 130.7 to 120 million years ago. Jehol localities yielded thousands of almost complete and fully articulated skeletons. And the bird fauna from Jehol accounts for roughly half of the total recorded global diversity of Mesozoic birds. And quite a lot of their fossils include a mixture of advanced and ancient species from both Jurassic and Cretaceous. And the true modern birds, which are members of the crown group Neornithes, are mostly from the post-Cretaceous radiation. So these radiated out after the KPG. However, there is some fossil evidence for the Cretaceous species. What came first, the chicken or the feathers? So feathered dinosaurs were first found in China in 1996. However, it's thought that now simple feathers had evolved further down the evolutionary tree. And this is because there were feather-like structures which were found in other dinosaur clades, e.g. The Ceratopsian Psittacosaurus, which have these kind of feather-like structures on its back tail. This posed two questions. So how many dinosaurs had feathers, and what were their original functions? We found that because of the feathered dinosaurs in China, we can confirm that feathers evolved in the earliest coelosaurids, which are theropod dinosaurs, which include the compsognathids, the tyrannosaurs, the ornithomimosaurs, and the maniraptorans. The first feathers in most coelosaurs were most likely to be short filaments and were probably used for insulation and possibly even display. And then small paravians used these feather forewings and hind wings in flight by the late Jurassic, early Cretaceous. And this is, for example, Archaeopteryx and Microraptor. I was lucky enough to see this exhibition called Dinosaurs of China when it came into the UK in 2017. These are all my own photos, and as you can see, these dinosaurs and birds, they just have really beautiful feathers. So we have here Microraptor, Sinosauropteryx, Yiki, Confucianus, and Yaornis. And these are just absolutely stunning specimens they're just fully articulated and have feathers. Here is a kind of pixelated example of the Jehol biota ecosystem. And the Jehol biota is found in northeastern China, and it's primarily lower Cretaceous, and its fossils are found in the Yixiang Formation and the Zhufutang Formation. And this ecosystem was interrupted periodically by ash eruptions from volcanoes in the west. And the fossils that are found here there's quite a lot of them, and they're also really, really well preserved, often with articulated skeletons, soft tissues, colour patterns, stomach contents, and like twigs with leaves and flowers still attached. So the way that these organisms died was that they were probably washed into the lakes very gently, or were already in the lakes when they died. They do not show the damage seen in fossils formed by large floods. And then we find that volcanic ash is commonly interbedded with lake sediments, and so we think that ashfall might have quickly buried the fossilised organisms and created an anoxic condition around them to prevent scavenging from other creatures. Of extinction events, we often talk about the end Cretaceous Mass Extinction, also known as the KPG. And the KPG boundary is dated using magnetostratigraphy and radiometric dating. Magnetostratigraphy is the polarity of the Earth's magnetic field, which is recorded in rocks that contain iron-bearing minerals. And it found that the extinction only lasted around 0.5 million years. Radiometric dating, which is argon-argon dating, of the ashes that have been found at the boundary, dated the extinction to 66.032 plus or minus 0.058 million years ago. There's still debate as to what caused the mass extinction, despite it being one of the most studied points in geological time. So the most commonly accepted theory of what killed the dinosaurs was a meteorite impact. And this was first proposed by Alvarez et al. In 1980. As previously before this, the extinction of the dinosaur was a bit unknown, and they all thought that there was possible theories that they died from a drought, or their evolution they got too big and just died out. And the meteorite impact theory is based on an iridium layer that is found within the KPG layers in Italy and Denmark, and these have now been found in numerous sections worldwide. And the Chicxulub crater where the meteorite hit is in the Yucatan Peninsula in Mexico. And this crater is an impact crater from an asteroid that was about 10 kilometres in diameter. This crater is 195 kilometres in diameter and 20 kilometres in depth, and it's filled with Cenozoic sediments, meaning that this impact crater will have formed before the Cenozoic. A 2020 study concluded that the Chicxulub crater was formed by an incline around 45 to 60 degrees to the horizontal impact from the northeast. 4 pieces of evidence of the meteorite impact that occurred at the KPG boundary. The first one is an iridium layer. This has been found in numerous sections worldwide. Iridium is a platinum group element that is rare on Earth's crust, and it reaches the Earth from space usually, so we know that it had to have come from a meteorite. And there is a spike within the geological record of iridium at this time. The second is shocked quartz. Quartz doesn't usually have this sort of scratchiness to it, and it's been found in numerous sections close to the impact site. And these grains of quartz are like crisscrossed, and this is due to the pressure of the impact. The third piece of evidence is glassy spherules, which is kind of like glass that is formed because of a meteor impact. And these are found at the base of the boundary of the Cretaceous and Paleogene. And these spherules are produced when the rock is melting beneath the crater. And these were kind of chucked up through the air as the aftershock of the impact occurred. There was a recent paper, which I think came out last year or the year before, where these glassy spherules have been found in the gill arches of fish, which were found in this site called Tanis in North America, where there was a shallow inland sea. Finally, there is a fern spike. So this has been found in numerous terrestrial boundary sections of the KPG, and this is like an abrupt shift in pollen ratios from angiosperm, which are the flowering plants, to the gymnosperms, so such as ferns, and this is because ferns are one of the first plants that recover quickly after bad things such as forest fires and volcanic eruptions. So for example, in 1980, during the Mount St. Helens eruptions, ferns were one of the first plants to come back after this eruption. Alongside this, we also have examples of tsunami events happening in the marine sediments surrounding the Chicxulub crater. So it's really cool that we just have all these pieces of evidence for the meteorite. Been a few other suggestions as to what killed off the dinosaurs, and one of them being volcanic activity. And this is kind of primarily known from the Deccan Traps in India, where huge volcanic provinces are in India, and we find that there are 3 pulses of volcanic activity spanning the KPG boundary. And most people accept that large igneous provinces, such as the Deccan Traps, were the cause of other mass extinctions, such as the Permo-Triassic and the End-Triassic. And then other suggestions were multiple causes. So there are some people that believe that the decline of the dinosaurs and other taxa lasted for the last 5 to 10 million years of the late Cretaceous, meaning that they think that the dinosaurs were already on the decline, as well as a cooling climate. Or another theory is that all of these kind of merged together to create this perfect extinction event. There's been debate around whether dinosaurs were flourishing or if they were already heading towards a mass extinction during the Cretaceous that would have wiped them out regardless of the meteor impact or any other suggestions or theories. In 2021, there was a team of researchers from the Imperial College in London, University College London and the University of Bristol in the UK, and they modelled that the environmental changes and dinosaur species distribution in North America, and their results found that the dinosaurs were not in decline before the meteorite hit. And this study found that the changing conditions for fossilisation in the Cretaceous meant that the previous analyses of the number of dinosaur species may have been underestimated. The further readings, as well as some PBS Eon videos, which are really, really useful videos produced by PBS on dinosaurs and other extinct creatures and events. However, I've just linked the ones for the dinosaurs, as well as any Paleocast podcasts, and these are all just really interesting podcasts. I listen to them on my commute to work every day. So yeah, really interesting. Dinosaurs are just great. These are the references for this week's lecture. We are talking about one of my absolute favourite topics within paleontology, and that is mammalian evolution. So we'll be looking at what mammals are, mammalian evolution pre-Mesozoic, mammalian evolution during the Mesozoic, and mammals after the end Cretaceous Mass Extinction. So thanks for listening to this lecture this week. You can find Safe Cultural Heritage Group on all these links, and you can find me on these links as well. If you have any questions, please let me know. And yeah, I'll see you all next week. Bye!